So today we're going to talk about naming acids, and this is covered in your book on pages 114 to 116. So there are two types of acids. There's binary acids and oxyacids. So just based on the word themselves, you should be able to figure out that binary means two. So there's going to be two parts to that acid. Oxyacids have the word oxy. They're going to have oxygen in them. And that really is the distinguishing characteristic between the two. So let's talk about binary acids first. So remember, I just made something move. That's crazy. Remember, binary means two things. So here are the two things that it's made up of: hydrogen and a nonmetal. So anytime you see an acid that has a hydrogen and a nonmetal, you're going to follow these rules. When you name a binary acid, you're going to use the prefix hydro, name the nonmetal, and end with the ic suffix. So, for example, you have HBr, so you know it's binary because it contains hydrogen and bromine. So hydro is your prefix, ic is your suffix, hydrobromic acid. Okay, easy enough. So go to page 115 in your books, and at the very top of the page, there's a number 2, and it's a C, D, and an E. Name those acids. So hit pause, because the next slide has the answers. Alright, so check your answers. For C, you should have had hydrofluoric acid. For D, hydroiodic acid. And for E, hydrosulfuric acid. Remember, sulfur is one of those weird ones where you don't drop the UR before you add the suffix. Somebody asked earlier, these could also be named as nonmetal compounds. So HF could be called hydrogen monofluoride. But the difference with what we're doing today is that we're naming them as acids. So as an acid, we call it hydrofluoric acid. All right, let's talk about oxyacids. So it's an acid, so you know it has hydrogen. It's an oxyacid, so you know it has oxygen. And then there's going to be something else. Excuse me. In order to name these, you're going to have to recognize the polyatomic ions. Remember, that's that ugly chart on page 46 in your book. So you might want to mark that page in your book so that you can flip back to it pretty easily. This little chart here is just a way to organize the notes that are on in your book about oxyacids. So the way you read the chart: if the polyatomic ion ends in 8, then the acid is going to end in IC. If the polyatomic ion ends in ite, then the acid is going to end in us. Hypoite is a hypous acid. Per-8 ion is a per-ic acid. Okay, so that sounds kind of weird, but let's go ahead and just do some examples and see. So let's say that I give you, let me pick up a pen here. Let me give you that ion. So then, to make it an acid, remember H is +1, so you would just slam them together like this. So this ion is called chlor-8 ion. So it's going to follow this rule. So it's going to be this acid. So this is chloric acid. Okay. You're going to want to keep this chart nearby or recopy it somewhere where you'd have easy access to it. Because now I want you to copy these on the top of page 120. There's a blank space up there. And then I want you to name these. Okay? Pause the video while you copy the questions. And you want to copy these symbols down too and the names so that you'd have something to practice from later. But copy the symbols, you name them, and then the answers will be on the next slide. Okay, so I'm going to show you how to do this with the steps that I just talked about earlier. So you have to recognize that ion. And that ion is oxalate. So it ends in 8. So this is oxalic acid. Okay. The next one, that is sulfite ion, ends in ITE. So remember from this chart, if it ends in if it ends in ITE, then it's going to be an us acid. So this is, remember sulfur is a weird one. Sulfurous acid. So here are the answers to those 5. Pause the video while you correct your answers. Based on the name of the ion, you actually know ions that aren't even on the list on page 46. And because you know a whole bunch more ions than are even on that list, you can name a whole bunch more acids. So let me show you how this pattern works. You have to remember this order where it goes per 8, then ite, then hypoite. And this column here tells you how many oxygen atoms we have. So let's start off with one that you know off of your chart already, just to see how this works. So this is on your chart. And you know that this one is chlor-8 ion. And why you need to know which one's the 8 ion is because this number of oxygens is important, because that's what N equals. So N equals 3 for this family of ions. So per chlor-8 ion should have 4. ClO4 minus would be per chlor-8 ion. If you had ClO2 minus, it would be chlorite ion. And if you had ClO minus, it would be hypochlorite. Now, if you go back to look at your chart on page 46, that's exactly how it goes. So let's try this with one that isn't on the chart. So let's try this one. SO42 minus is called sulfate ion. So I want you to answer these 4 questions. So pause the screencast and jot down answers. Just find a space somewhere where it talks about, somewhere on page like 115 to do this. Okay, so if sulfate ion is the main one, then sulfite is going to have one less. So sulfite should be that. And that's actually on the chart, so you could double check yourself. So sulfurous acid, you have to think back to this chart where the ite ion turns into the us acid. And so sulfurous acid is H2SO3. Okay? Persulfate ion, if it existed, would be one more oxygen. Persulfuric acid would be that. So check your work, see if you got that right. You try. Copy these questions and write the answers on the top of page 122. There's empty space there. So copy the following symbols. Write the symbols for the following names. You need to copy these names and then write down what you think the symbols are. So I'm just reminding you, remember that ions have superscripts, but acids do not. So real quick, ions have superscripts, acids do not have superscripts. So be careful. All right, pause the video while you're coming up with those answers. So I caught an error on here. Hopefully you saw it too. Since this is an ite ion, this is going to have to be an us acid. Sorry about that. So here are the answers for all of these, and I think that these all work out right. Some of these you have to do some extra steps. When you get to E, I wrote out what bromate ion is, but this is asking for per bromic, so you need one more oxygen. So that's why there's 4, not 3. You know that CrO4 minus 2 is chromate. This is the us acid, so you need the ite ion, so that's one less. So F is H2CrO3. Polyprotic acids are the last kind of acids that we need to talk about. So polyprotic acids are acids with more than one ionizable hydrogen or proton. For example, hydrochloric acid is monoprotic. Its symbol is HCl. It has one H. Sulfuric acid is polyprotic. More specifically, it's a diprotic acid because sulfuric acid has the formula H2SO4. There's 2 hydrogens. Phosphoric acid is triprotic because it's that symbol. It has 3 hydrogens. Okay, so that's the end of the screencast. So to earn points for your classwork today, there are some pages that you're going to need to take pictures of in your books where you took notes from the screencast, and you're going to turn that in on eBackpack. So I need you to take a picture of page 115, page 120, and page 122. Pictures, and it's where you took your notes on those pages. Page 115, page 120, and page 122. You were supposed to copy some questions and then write down answers. I just need to see that you did that. That should be turned in on eBackpack. Your homework for over the weekend, and if you have time during class today, you should go ahead and start it. It's not due till Monday though, but it is page 125 and 126. Page 125 and 126, everything on both pages. That's due Monday by 8:50. Remember, no tutorials this afternoon, no tutorials Monday morning, but I will be in my classroom Monday afternoon for anybody who needs me. Have a good weekend.